Okay. Okay, so I told you guys in the lecture, we have input devices and we have output devices. So output devices like 7-segment, LEDs, LCD. Okay, I made it very easy. I told you if the microcontroller send this data to the device, so this device should be output device. If the microcontroller reads data from the device, so it's input device. Is that okay? This is the first thing I mentioned last time. Also, the other thing I mentioned is any input or output device has to be connected to a port. This is exactly similar to what you do in your computer when you connect the mouse to USB. The USB is a port, okay? So what is port? I'm gonna give you some details about it, but for now, I made it very clear, any input. So there should be a port, as I'm gonna explain later in some details. Just give me 1 second. This pen is not working. This pen is not working. This one is working, but the pen is not working. So what I'm saying here, guys, is a port is like a circuit, like you have electronic circuit here. This electronic circuit, where here you have to connect the input or output device here, okay? So that this device is connected to the internal system, as you will see right now. So I'm gonna give you more details, okay? So as you see here, guys, you have a port, input port or output port, as you see here. Any input output device has to connect to this port, okay? The other thing is, let me see if it can work here. Looks like I'm going to use the board. You know, looks like I'm going to use this board. So what I want to say here, guys, every port should have pins on the microcontroller, pins. This is where you connect the input, the device itself, okay? This is how you hardwire, right? So every port should have pins on the microcontroller. This is number one. Number two, every port should have a number of registers that can be used to control the operation of the port. Okay, I'm going to give you more details, but for now, every port should have pins, also should have number of registers. So I'm going to give you details about this. Okay, but this is starting with the pins first. And this is where you have to connect the input-output device. For example, as I'm going to explain today, we have LEDs here. We have 8 LEDs, okay? These LEDs are connected to port B, okay? So what you have to do is you have to physically connect the electronic, you have to connect the circuit this way, right? It's a pin here, okay? So number one, let's see what ports we have. You told us we have a number of ports. Yes, we have. Okay, so tell us what ports we have and where are the pins of these ports here on the microcontroller here. Okay, you will see. That's what I'm going to explain now. So, yeah. So if you look at the microcontroller here, guys. Yes. Okay. So you can see here. Yes. Okay, let me. Okay, you can see here, guys. This is our microcontroller. This is the chip here. Okay, this is the chip, and these are the pins. All the pins we have here. All the pins. You can see here, guys.
we have these pins for port A. We have port A here. These pins for port A. The way this port is made, we connected the keypad to port A. So when I explain how the keypad is working, I'm gonna talk about port A, because port A is used to connect the keypad, as I'm gonna explain later. We have port AEG. We're not gonna use it in this course. We have other ports, like we have port S, we have J, we have M, we have port P. I'm gonna talk about here and here. So port P, it has eight pins, as you see here, guys. PP0. PP0 means this is port P, pin number 0. PP1, PP2, PP3, PP4, PP5, 6, 7. Okay, so port P has 8. Port A has also 8 pins, as you see here. Port A, pin number 7, pin number 6, 5, 4, and 0. So this port, as I mentioned, is used to connect the key for the keypad. This one, as I'm going to explain later, this one is used for, we have something we call it RGB LED. So I'm going to explain later, an LED, but RGB. So it can give 3 colors, as I'm going to explain later. So it's connected here. Also, we have port K, as you see here, guys. BK0, BK1, BK2, BK3, and 4 and 5. That's all what we have for port K, right? Port K, as I'm going to explain, they are going to be used for the LCD, as I'm going to explain later. Also, we have port T, as you see here. PT0, 1, 2, 3, 4, 5, 6, 7. So we have 8 pins for port T. Port T, this is where the buzzer is connected. Okay, as you will see, the buzzer is connected to BT5. So BT5, the buzzer is connected here, BT5. Anyway, we have port J. I'm going to tell you today how it is used. We have port B. So port B is used to connect the LEDs and also the 7 segment. So the 7 segment and LEDs are connected to port B, right? Also, we have port H here and here. This is PH0. Again, don't be confused. PH0, P means port. H means this is port H. Pin number 0, pin number 1, pin number 2, pin number 3, 4, 5, 6, 7. Port H is used for the switches here and the 7 segment, and the push buttons as well. Okay. So these are the main ports we have here, guys. As I told you, every port should have a pin, as you see here. Okay. Also, I told you, every port should have registers. Now I'm going to move to registers. Okay. So what kind of register you have for every port? At least we have 2 registers. One register, we call it. So every port should have at least 2 registers. One register, we call it data direction register. Okay. Or sometimes we call it DDR, data direction register. Okay. How this one is used, or how we will use this one, data direct. Every port should have this register. Why? How can we do with this register? Okay, look here, very easy. Look here, guys. The way they made it is every port, you can program it, input or output. Let me say it again. Look here, guys. Look at the idea. What is the idea? I'm going to tell you what is the idea. The idea is that if this is input, if this is an input port, okay, that means the circuit here should be this way. The current has to go, the electronic circuit has to be connected this way because it's input, right? If it is output, that means the current has to be go this way, right? The current, please, can you see okay, guys? So it has to be connected this way, okay? So what I'm saying is that the way they made They made this microcontroller that every pin or every port can be programmed, input or output, and it's up to you. Why they made it this way? They made it this way to give us flexibility. Why flexibility? In your project, you need too many input ports. Okay, you can program all of them input if you want, right? Or you need too many output ports. You can program all of them output. You get what I'm saying? So again, let me say it again. So what I'm saying is, every port you can program it input or output to act as input or output. Okay. So how I can do that? How I can program this port? By the way, it's not only port. You can program every pin, not port, not the whole port. Every pin. That means you may have one port. This pin is input and this pin is output, right? First, what do you mean by programming? Very simple. Programming means, should I connect the circuit this way or should I connect the circuit this way? You have to do some connection somehow because it's not the same. You got what I'm saying? So let me tell you now what I want to say. What I want to say is that very easy. Every port should have a register. This register is called data direction register. Is that okay? This register is used to program every pin in this port, input or output. Okay? Let me clarify. So now, for example, just an example, if I want to talk about port B, okay? Port B should have a register. It is called DDRB, data direction register for port B, right? This register is just a byte. It's just a byte. Every bit here, it's 8 bits. Every bit here is used to program one pin here, one pin. So this one should be used to program this pin. This one should be used to program this pin, which is PB0. This is PB1, and so on. Is that okay? Very simple. So if I need this pin to be input, so I have to put here 0 in this pin to program it input. If we want to program it output, this pin just to put 1 here. Very simple, right? And this programming should be done only one time at your program. It's the very beginning. This is like initialization. This should be done only one time at the beginning of your program. You have to do it, right? So again, let me say very simple. What I'm saying is that, guys, for example, I know these switches are connected to port H, and port H is input. The way I want to use it input because I connected input device to port H. That means in the very beginning of your program, you have to do initialization. In this initialization, you have to configure port H as input all the time, because this is how I made this board, right? For port B is connected to the LEDs. That means it is output. So you have to program it output all the time. Yes, all the time. And this should be done only one time. One time should be enough in your program. Is that okay? So let me say conclusion. Conclusion is any port you are going to use in your program, you have to program it input or output, right? How? Very simple. You have a register, just to put 0 and 1 here in the corresponding bin. Okay? For sure, if the whole board input, you can just put 0 everywhere. If the whole board output, just put 1s everywhere, right? And this should be done only one time. Okay, so that means this is something we are going to do in all programs all the time? Yes, okay. But what does it mean? As I told you before, it means the 0 or 1 you put here, this is how you are going to connect the circuit. You're going to connect the circuit this way, or you're going to connect the circuit this way. Is that okay? So I have here a diagram to explain what I mean exactly here, or what I want to show here, what I mean by programming here. I mean, actually, yeah. So here I show you one example here. So this is a pin. This is a pin for a port. Okay. So you can see here, guys, this pin, we have 2 switches here. This is switches, electronic switches. We call them tri-state buffer, right? This is how it works. If you put 0 here, that means this switch is open. Electronic switch is open. Here, because this one has a bubble here, as you see here, if you put 1, it means it's open, right? Same thing here. If you put 1, that means you can make it short circuit. If you make it 0, right? If there is a bubble and you put 0, you make it, you connect the switch. It's electronic switch. So as you see here, guys, every pin should have two switches this way. And the way I made these switches is, it's impossible that both of them are on, as you can see here, because this one has a bubble, this one doesn't have a bubble. That means if I put here 0, so this one is on and this one is off. If I put 1, so this one is on and this one is off. Okay? So again, if you don't understand, that's fine, but I just wanna tell you, I want you to fully understand what happens when you put 0 here and what happens when you put 1 here. Also, I want you to fully understand why I need to do this programming. Simply, as you see here in this figure, here, when I put 0 here, as you see, guys, you actually are gonna connect this one. This one is open. That means, because this is a switch, that means the circuit is gonna be connected this way. The circuit, the electronic circuit is gonna be connected this way, okay? So this 0 is coming from data direction register, as I told you, okay? Here, if you put here 1, so actually the circuit is gonna be connected this way, as you see here. That's why here I'm putting like LEDs or output device. Is that okay, guys? Any questions? Okay, just I'm gonna say the conclusion in 1 or 2 statements, okay? Number 1, any port you are using in your program, you must configure it input or out, okay? And this configuration should be done only one time. If you have a loop, there is no need to put it in a loop, because once you configure it one time, it's gonna stay there because you're not gonna change it, okay? So this one thing. The other thing, how can you do this configuration? Very easy. You have a register. This register is called DDRB. Sorry, DDR. So that means we have DDRA for port A. We have DDRB for B, and so on. Is that okay? So for every port, we have a register. We call it DDRA, B, and so on to configure this port. Is that okay? Okay. Now, I want to tell you something here, guys. We call it a register. We call it a register. However, the way we're going to program it is like a memory location. You remember, for register, we use name, like register A, register B, register X. We use the name of the register. But here, yes, we call it register, but actually the way you are going to do it like a memory location. That means every register here should have address like a memory location. And every instruction I taught in chapter 2 for a memory location, you can use it with this register. You understand what I'm saying? So we use like move. Okay, so you can use move here because this is I'm gonna treat it like a memory location. Okay, you understand what I'm saying? So it should have address. So you have to write an address. Okay, that means if I want to put 000 here, all what you have to do, you have to say, for example, move by, and then you have to put here, for example, number 0, comma, and then you have to put the address of port B, for example, the address of the data direction register for port B. Yes, you have to do it this way. Is that okay? Okay. However, we hate numbers. Numbers are going to make the programming difficult because always you have to remember, I'm going to use port A and B. Maybe in one program you are going to use multiple ports. So do I need to remember numbers all the time? No, we have a smarter idea. Yes, you have to put here a number because this is like a memory location. You have to put a number, right? But just to make programming easier, okay, because I don't need to remember too many numbers and use it. And if you make mistake, you put a wrong number, it's not going to work, okay? We like to use names instead of numbers. So what we did is we define all these addresses using equate. So we used equate, you remember? And we already defined this. So here we have DDRA, and then we put the address. We have DDRB, equate, and put the address, and so on. I did it this way so that instead of using numbers, I'm going to use English name. Okay? But keep in mind, this English name is going to be replaced by the address by a number. You understand what I'm saying, guys? So what I'm saying now, I'm gonna remove this one. I'm gonna put here like DDRB or H, whatever it is. Okay, and this one is already defined. You remember, there is a file we include in every program, right? This file has a lot of equates. So all these data direction register, they are defined there. Okay, so I'm gonna show it now. Look here, guys. So okay, thanks very much. Thanks. So here, guys, do you remember this file? I told you about this file before, and this is the file we define every time. You remember this number? This is the file. This is the file we include. If you look at this file, it has a lot of equate, as you see here. All the file is just equate, as you see here, right? So because we define, again, the idea here is we don't like to use numbers. I want to use English names instead of numbers to make programming easy. Okay. For example, I'm gonna search for DDRB. Yeah, look here, guys. So the data direction B should be number 3. This is address number 3. So instead of using number 3 to program the data direction or the direction of port P, I'm gonna just use the English name DDRB. You got the idea? So all of them are defined here. So DDRH is here. This is 262. This is the address, right? Let's see, DDRT. We don't have DDRT. The data direction register for port T. Yeah, it's here. Okay. So data direction port T 242. Is that okay, guys? Again, let me summarize what I'm saying. What I'm saying here, every port should have a register, data direction register. You have to use this register to program this port, input or output. Also, I said, every instruction we used before for memory location, you can use it here because this is like a memory location, right? So that is why here I'm giving you a lot of examples here, guys. Look here, for example, yeah, here, look here. For example, here I told you this one data direction register A is already defined. So all what you have to do something like that in your program. You can say, for example, guys, move byte FF to data direction register A. If I do that, so that means I configure all the pins on port A as output. Okay, because FF means 1 1 1 1 1. So all of them are output. So if I put 0 in data direction B, so I configure all. It's not working or what? Hello? Looks okay. Hopefully it's okay. Anyway, so what I'm saying here, guys, if I put here 0, so that means I configure all of them are input, right? Because I'm gonna put 8 zeros. If you put something like that, AA, for example, if you want to use move, so that means 0 1 0 1. So this pin is input output. Again, if you want to, it's okay if you want to do this way. If I do something like that, 0F, okay, that means the first 4 pins are output. Then the most significant 4 bits are input because you put zeros here, right? Okay. Hello. Okay. So also you can use bit set. Here I change the whole register or the whole byte. You can just use bit set or you use bit clear to clear some bits or to set some bits. Is that okay, guys? Any questions? Any questions? You understand what I'm saying? So every port you have, every port you are going to use in your program, you have to configure it input or output one time at the beginning of your program. That's it. Okay. The other thing we have here is, I told you for every port we should have pins. Okay, that's number one. Number two, it should have a number of register to control the operation of this port. I already explained one register, which is the data direction register. Now I'm going to explain another register. We call it data register. Okay, I already explained it in the lecture, if you remember. The second one, we call it data register. So what this one means, okay? Where is Suzuki? Is this two? Yeah. Okay, I explained something like that in the lecture, guys. I told you here, if you have here a pin, this pin is connected somehow to a byte here, right? So that if this pin is output, guys, if I in this byte, if I put 0, logic 0, you are gonna put 0 volt here. This pin, so every pin here should have one pin here. If I put here logic 1, you are gonna put 5 volt. You got what I'm saying? This is a register. This register is called data register. Data register. And every port should have a data register. You got what I'm saying? So the idea is that, so again, this data register should have address like a memory location. You got what I'm saying? So all what you have to do is, if this pin is output, all what you have to do, you have a byte, like it has address like a memory location, and you have to set some bits, you have to clear some bits. And that's what we have been doing many times, right? So you have a register, this register should have an address number, and then if it is output, so you have to write here 0, logic 0 in this byte, so that you put 0 volt here. Or if you want to put here logic 1, you're going to put 5 volt here. This is if it is output. If it is input, it's going to be a little bit different. If it is input, so this pin, we have pins here. This is connected to the data register here. Okay, again, every pin should have a bit here. Okay, so on this pin, if I put 5 volt here in this pin, it automatically is going to be logic 1, right? And just all what you need just to read it to see if it is 1 or 0. You got what I'm saying? Here, if you put 0 volt, so 0 volt is going to come to here, and then you have to check this bit. You understand what I'm saying, guys? Conclusion. You have a byte. In this byte, every pin should have every bit should have a pin, right? And all what we're going to do all the time we're going to do that. If I want to put here 0 volt, I have to put logic 0 here in this bit. If I want to put 5 volt, I should put 1 here. Very easy. We'll do it all the time, right? For example, if an LED is connected here, so that means when I put here 1, I'm going to make here 5 volt, I'm going to turn it on. This is how we can turn an LED on, right? But if it is input, if this is an input, so actually all what you have to do, you have a byte and you need to check some bits. And we have been doing this many times. We did it many times, right? So I have to check some bits. Okay, guys? Again, so now, so this is a register, right? We call it data register. This register should have address. That's true. So do I need to remember the address of the data register for each port? The answer is no. Similar to what I did in the data direction register, I did the same thing right now. I'm going to use English names, okay? And they already defined in the file. You can just use English names instead of numbers because it's just easy, right? So here, the way we define the English names here in this file is, for port A, we use port A. This is how it is defined. So you can just use the word port A, and port A is going to be replaced by the address. Or is that okay? Again, any instruction we used before for memory location, also you can use it with this one. Again, we call it register, but the way you are going to program it, it's not like a register A or B. So you're not going to use names. You are going to actually use, you have to use addresses, but just because we like to use names, I'm going to do it using equate, right? So you are going to use names, that's okay, but these names are going to be replaced by addresses, by numbers, okay? So anyway, so as you will see right now, guys, if I want to read port A, okay, so this one port A here, this is the byte. Every bit here in this byte can tell you what is the voltage here. If it is input. If it is output, every bit here, if you put some value, 0 or 1, you are going to put 5 volt or 0, 1 on the pin. So this is what you have to use for port A. For port B, you have to use port B. This is how it is defined in this file. For port E, it has to be this way. For port H, for some reason, they didn't define it this way. They made it PTBH. You can change it if you want. Just to go to the file and make the changes in the file. So this shouldn't be too difficult. So PTH, right? For port J, you have to use BTJ. This is how it is defined in the file. Okay, so you can change it if you want. For port K, we use the complete letters of T. Of K, so we say port K for MBTM. For port T, we say BTT. Is that okay? Let me show you. Let's go to the file and show you, for example, PTT, how it is defined here in this file. Again, in every lab you did so far, in the 7 labs, we did 6 labs, right? In the 6 labs, you remember, you always include this file in the very beginning, right? So again, you don't need to do anything. You already included the file. You can just use the English names. So for example, if I look for PTT, as I told you here, yeah, look here, guys. BTT is equivalent to 240. You got what I'm saying? So again, instead of remembering 240 and use the number 240, we want to make it easier. You can just use the English name BTT, okay? Same thing for if I go for port B. Yeah, look here. Port B, the address is number 1. This is how the address is, number 1. Okay, guys? Okay, conclusion. Again, if I want to use any port, okay, there are 2 registers I have to use. One register is the data direction register, as I explained before. DDR, and then you can put A, B, H, whatever. This is one for programming, and we are going to use this one time. That's it. Just for configuration. You want to program the board, input or output. That's it, one time, right? However, if I want to read the pins or I want to write to the pins, you have to use another register. We call it data register, and these are the names you have to use. And usually you are, yeah, these are the names you have to use. And usually you are going to use this register many times in your program. Read, write, read, write. So it's not like the initialization. Initialization only one time and that's it, okay? So I want to show here some examples for this one. Look here, guys. When I say, for example, again, remember, very easy. Any instruction I taught before for memory location, you can use it with these registers. This is like a memory location, okay? For example, I can say, move byte 35 to the location 0. Again, I don't like this one because again, we hit numbers. This is exactly similar if you say, move 35 port A. It's exactly the same thing. Because the port A should be address 0. And this is how it is defined in the file, okay? But for sure, it's easier for me to use English names than using 0. But anyway, the code warrior is going to remove this one and replace it with the number Z. Anyway, so I can say something like that. So I want to, here, I'm gonna write to the port. If the port is output, you can write. You cannot read. Because it's output. By common sense, this is output. You can only write, you cannot read. If the port is input, I can read. I cannot write. Makes sense, right? Because it's input. So input means it can give me data, but I cannot write. Okay. So here, if I do something like that, that means port B is input. Is output because you are gonna write to it. I can do something like that. store A in port B. So here, the value of A is going to go to port B. Okay, so B here is output. I can say move by this number to port B this way. Okay, very interesting. That means if you look at the pins, of port B, you will see this number 110, 10, 5 volt, 5 volt, 1 volt. Sorry, no, 5 volt, 0 volt, 5 volt, 0 volt, and so on. And so on. So you can load if it is input and so on. Any questions? Okay, guys, any questions? Okay, great. So now I'm gonna start explain. I'm gonna start now explaining again. What I explain right now, we are gonna use it all the time for all ports. And as I told you, all the input-output devices here are connected to ports, all of them. Is that okay? So now I'm gonna start with LEDs. As you see here, guys, we have 8 LEDs, 8, right? These 8 LEDs are connected to port B. This is how they connected it here. So they connected to port B. Internally, there is a connection between these LEDs and port B, pins, the pins. So as you see here, guys, we have one LED here is connected to PB7. PB7 means port B, pin number 7. And this one is connected to pin number 6, to pin number 0. So we have 8 of them connected this way. Is that okay? And then, look here. And then all the cathodes are connected together, as you see here. And then it's connected to BG1 this way. I'm going to tell you why. Connected to BG1 this way. Okay, I'm going to tell you why they made it this way. Look here, guys. Look at the idea. If for BG1 here, if I put here 0 volt, okay? So if I put here 0 volt or logic 0, so it's going to be 0 volt here, okay? Look here, guys. If I put here on this pin 5 volt, so this one is 5 volt, okay? So as you know how the LEDs work, so you should know this one. The LED should work this way back. So we have here, this is what we call anode. This is the cathode, as you know, right? So the voltage of the anode has to be greater than the voltage of the cathode to turn it on, right? That means if I put here 5 volt and I put here 0 volt, that for sure we need a resistor here. This resistor is used to reduce the current. Otherwise, it's going to burn out. If the current is too high, you're going to burn it out. So anyway, so 5 volt here, 0 volt, that means you are going to turn it on, this electronics. Is that okay? However, so here the voltage here has to be greater than here. However, if I put here 0 volt and here 0 volt, you turn it off. Is that okay? Also, if I put here 5 volt and I put here 5 volt, it's off. Okay, right? So to make it on, the voltage at the cathode has to be higher than the voltage at the anode. So very simple. Look here. That means if I put here 0 volt on BG1, 0 volt, very simple. So if I want to turn one LED on, I have to put 5 volt here. If I want to turn off, just put 0 volt. That's it. Is that okay? So to make it simple, this is port B. Port B should have a register. Okay? All what you have to do is the register. The register, in this register, every bit here is connected to one pin. All what I have to do is, if I put 0, so actually you turn the LED off, right? Because if you put here logic 0, the pin should have 0 voltage. And because this is here 0 voltage and here there is 0 voltage, you turn it off. Make sense? Okay. If I want to turn the LED on, all what I have to do is just put one here. Very easy. You just have a byte and you can bit set or bit clear. Very simple. Just a programming. How can you program it? Very simple. Just what we did it many times in chapter 2. You have a byte and one bit. Okay, set clear, set clear. That's it. Is that okay? This is if you put here 0 volt, right? So now I want to answer a question. Why is he connected this one to BG1? Why it was not like ground here? They can put here just a ground. They can connect here to the ground. This, I'm going to tell you why they made this way. Okay, they made it this way because BG1, which is pin number 1 on port J, BG1 is going to be used as enable or disable for the 7 segment. So here, the way we designed it, I'm going to tell you why they made this way. We would just put ground here, yes, but they didn't make it this way. Just they connected it here, yes. They connected it here because I'm going to use BG1 as enable or disable for the 7 segment. What this means? I'm going to tell you what it means. It means if I want to disable the 7, enable or disable for the LEDs. I'm sorry. Okay. So what this means? It means if I want to disable LEDs. What do you mean by disable? It means it's not working. So I don't want the LEDs to work. Okay. So very simple. In BG1, I can put here 5 volts. So in this bit, I can put 1. When you put 1 on this bit, I'm going to put here 5 volts. Think about it. If you have here 5 volts and you put here 5 volts, the LED is off. You have 5 volts here and put here 0 volts, the LED is off as well. You got what I'm saying? That is why BG1 here, BG1 is used to enable or disable LEDs. Okay? How? If I want to use the LEDs, okay, so I'm going to put 5 volts on BG1, okay, so to disable the LEDs. If I put 0, now the LEDs can work. What do you mean by what? They can work? It means you can turn on and off, on and off. However, if you put here 5 volts, they are going to be off all the time. Whatever you put here, it doesn't matter. If you put here 5 volts and we have 5 volts here, it's going to be off. Okay, guys? So let me say it again. So now for the LEDs here, guys, we have 8 pins on port B. Every pin can turn on and off the corresponding LED. Okay. Also, we have 1 pin on BG1. This one can enable all the LEDs, okay, or disable them. If just I put 5 volts, so LEDs are off. Okay, guys. But why they made this way? Why? It's interesting idea to have something like enable or disable. It's an interesting idea, but why they made this way? They made it this way for a reason. The reason is we have port B. We have port B. Port B is connected to LEDs. Also, port B is connected to every 7 segment we have. We have 4 7 segments. All of them are connected to port B. Okay, guys? So we have 4 7 segments, as you see here. We have 8 LEDs. All of them are connected to port B. That means whatever I put in port B can be shown in all of them. That's true. If all of them are enabled. You got what I'm saying? So what they did is, for the LEDs, we used BG1 as enable or disable. For every 7 segment, we used PP0, PB1, PB2, PB3 as enable and disable. You got what I'm saying? So that it doesn't make sense. Whatever shown in port B should be shown on all of them. It doesn't make sense. Only one of them should be on at a certain time, and everyone is off. Again, the way we are going to use it, don't worry about the 7 segment for now because I'm going to teach it later. But the main idea is that all of them are connected to port B. But the way we are going to use it, only one. So this one can be on, or this one, or this one, or this one, or this one, right? Because it doesn't make sense that you turn more than one on. And the number you put here in port B is going to be shown on 2 of them. It doesn't make any sense. You get what I'm saying? That's why the way they did it, for every device here, they have enable here. And this enable, if you put here logic 1 or 5 volt, you actually turn this one off. Same thing here. You put 5 volt, so this one is off. 5 volts, this one is off. 5 volts, this one is off. 0 volts, this one is on. That's how you can only make. Again, someone can ask me, but why? So that means I cannot use the LEDs and 7 segment at the same time. No, you cannot. Based on the design, they made this board this way. Okay. So someone can ask me, so why is it made this way? What if in my project I need to use 7 segment? Also, I need to use LEDs. Okay. Again, look here, guys. They made it this way because this board is made for education. So they want to put too many things here. You can understand that's why they made it this way. However, when you make your own project, you may design it in a different way. Okay. So for example, you can use port B for LEDs. You can use another port for the 7 segment. You understand what I'm saying? So I'm just saying this is how this port is made. The way it was made, they connected all of these to port B. So whatever I put in port B is going to be shown in all of them if all of them are enabled. So that's why they made for every one of them enable or disable. And the way you are going to use it, only one of them is enabled at a certain time. Is that okay? Any questions? Okay. So now, guys, I'm going to show you now how can you make a flashing LED. So for example, I'm going to select one LED here. I want to make it flashing. Turn on, off, this way. Okay. How you can make it? Very simple. Look here, guys. I'm going to put 5 volt, okay, and keep it for 1 second. Then put 0 volt, keep it for 1 second, and repeat. That's it. Look what I'm saying? So I want to make it flashing. So remember, every LED should have one bit in a byte. Bit set to turn it on. Bit clear to turn it off. That's it. But when I turn it on, I'm gonna wait some time because I wanna make it flashing. So I wanna turn it on for some time, then off for some time. So I have to turn it on and then I have to wait some time. Okay, so if I wanna make flashing every 1 second, so I'm gonna turn it on, wait 1 second, turn it off, wait 1 second, then and so on, repeat. Okay. So how can we do that? That's what I'm gonna explain in this program right now. Okay, guys. So this is how we will make the program, guys. Here, in the program number 1, you have to configure pin 0 of port B, okay, as output. Also, I have to configure BG1 as output because I'm gonna use also BG1. This configuration one time at the beginning of the program. As I said, you should not use any port before you configure it input or output. Okay. So number 1, you have to configure PB0 because I want to use the LED at PB0. Also, I have to configure BG1. Okay, because BG1 is the enable. Also, here I have to also disable the 7 segment. Why? Because as I told you, if you want to use the LEDs, you have to disable this one. Otherwise, all of them are going to work at the same time. This is not going to damage the board if you do that, but it doesn't make sense because you are going to see random. You are going to see random shapes here, just random. Okay, so all of them can work at the same time if you want, but it doesn't make sense. Okay, anyway. So the way we are going to do it is, if you want to use LEDs, you have to disable the 7 segment, and the way how you can disable them? Very simple. PB0, PB1, PB2, PB3, I'm going to put 1, 1, 1, 1, logic 1. When I say logic 1 means 5 volt, okay, to disable them. So again, this is configuration. So here, guys, these 2 steps are just the configuration, and this should be done only one time at the beginning of your program, just the configuration, right? So, and then your program should start actually, or most of the time we are going to be here. Number 1, you have to, also you have to pull BG1 to enable LEDs. That's okay. So actually, most of the time we start from here. Look here, guys, what we are going to do. Pull PB0 high to turn his LED on. Then wait 1 second. Pull PB0 low to turn the LED off. wait 1 second, and then repeat. So all the time we're going to be here. This is a loop. Okay, guys? So this is a loop. Okay? Very simple. So now the problem became something you are very familiar with. You have a byte. In this byte, just 1 bit. Put 1, wait 1 second. Put 0, wait 1 second. Put 1, wait 1 second. Put 0, keep repeating this way. Okay? That's why you are going to see flashing. Because if you connect this pin to the scope, you will see something like that. Once it's high, 5 volt for 1 second, 0 volt for 1 second, and so if you connect this pin to the scope, okay, and that's actually, I have a picture here. So I connected this pin to the scope, and I saw something like that. Look here, guys. This is 1 second, 1 second, 1 second, 1 second, and so on. Is that okay? That means I can generate a square wave easily, very easy, right? So here, what I did here, yes, I did flashing, but this flashing is like square wave, right? High, low, right? And then you can just to control, you can play in the time. So you can change the time, turn it for half a second to make flashing faster. Okay, you will see right now, it's very easy. So let's see how I made the program here. Look here, guys. So this is the configuration I told you about. This is the configuration. I'm going to give you the details of this configuration. And this is the loop. So most of the time we're here. We're doing loops here. Bit set, wait 1 second, bit clear, wait 1 second, and so on. So let me give you the details. So the configuration only one time. I saw some students that put the configuration inside the loop. You don't need to do that. Once you configure it in input or output one time, it should be enough. Okay, it doesn't make sense to put it in the loop. It's not a mistake, but you don't need to do that. Just a configuration one time and that's it. Okay. So anyway, so I'm gonna show you how I made it. So number 1 here, guys. Number 1, data direction register. You have to think what ports you are gonna use right now. I'm gonna use port B, PB0, 1 pin on port B. Also, I need to configure BG1 as well, because this is used enable for LEDs. Also, I have to configure PB0, PB1, PB2, PB3, these 4 pins. Also, I need to configure them output, all of them output. Is that right? So all of them should be data direction register. So I have to use 3 instructions for data direction register. 1 for port P, 1 for BG1, and 1 for this one. So let's see how I made it. So the way I made it, guys, here, data direction register here, okay? For port J, bit set 0, 2, right? So here, that means, as I explained, so here, this is port J, okay? So here, this pin, I wanna set this pin. I wanna put 1 here because this pin is BG1, right? So pin number 2, okay? This one is actually this is a mask, so it should be 0, 0, 0, 1, 0. So 1, 0. So this instruction here, you actually are gonna set this bit on the data direction register in order to make BG1 output. BG1 output. Is that okay, guys? So now I am done with BG1. Now let's think about port B. Yeah, look how I made it in port B, guys. B set data direction register for port B, okay, and then 0, 0, 0, 1. So here I configure BB0 as output. Is that okay? Again, if you are confused, data direction is just going to be replaced by a number, by address, as I told you, address. Okay. Anyway, so now what is left? Port P. Says the way I made it, I configured the whole port data direction register P FF. So here I put FF, so I configure the whole port. Maybe this is not a very good idea. You know why? Because I'm interested in 4. I'm interested only in 4 bits, right? PB0, PB1, PB2, PB3, only 4. So what I did here, I configured 8, all of them. It will be okay to do that if you configure all of them, because I'm not going to use the other 4.
Okay, so it would be okay. However, if you are using the other four for something else, it would make trouble. So, okay, so is there a better way than what you did here? Yes, the better way is I can say, let's say, data direction register for port P, and then I can put here 0, 0, 0, 0, 1, 1, 1, 1. So by this way, I can only configure the four bits I need, not the whole port. Okay. Again, here it is okay because I have eight pins. I don't care about the other four. Okay, because I'm not going to use them. But if you are using them in other when you have a big program, it would make trouble. Okay. So maybe this is a better idea than what I did here. You can just make bits. Okay. Anyway, so using this instruction, guys, this one here, and this one here, and this one here, I configured the ports I need as output. Okay, because all of them are output. Any question? Every time you use the LEDs, you have to do that all the time. Okay, but here I'm using only one LED. That's why I configure only one. In the future, if you want to use more than one LED, so you have to configure more than one. Here, okay. Now, what else I should do now? What else you have to do is you have to put here 0 in BG1. In BG1, you have to put 0 in order to enable LEDs. And then I have to put here 1, 1, 1, 1. Right? Again, the easy way, you can use move instruction, or you can use bit set, bit clear. Bit set, bit clear, very easy, right? So whatever you like. So for example, here, for port, let's start with, for example, if you see here, guys, port J. So for port J, I used bit clear this way, very easy. So I just clear, but here I clear BTJ. Don't be confused. What is the difference between BTJ and DDRJ? Yeah, that's what I told you. Every port should have 2 registers. One for configuration and the other one for the data itself, if you want to read or you want to write, right? So this one is this is for direction, but this is the data itself. Okay. So here by doing that, I actually this pin I put 0 in this pin in BG1. So after this instruction, BG1 is 0. Is that okay, guys? Okay. Now I'm okay. I'm okay with BG1. Now let's port P here for the 7 segment. BB0, BB1, BB2, BB4. So the first 4 bits should be ones, 1, 1, 1, 1, in order to disable them, 1, 1, 1. Anyway, so the way I did it, I just use move, but again, move, sometimes move, makes a trouble, move, because in move, I'm gonna write in the 8 bins. Yes, it's okay here in this example because I'm gonna use this 4 and I don't care about the other 4. But maybe in another example, you are gonna make a mess here if these 4 are used for something else. So anyway, so I think maybe smarter idea to use bit set or bit clear because I only care about these 4. So try to focus on these 4. Okay. So instead of doing what I did here, you can simply use bit set. So I can say use bit set PTP, comma percent 0, 0, 0, 0, 1, 1, 1, 1. Okay, so I can set the first 4 bits. So once you do that, PB0 until PB3, all of them should have 5 volts to disable them. Okay, any question, guys? So this is configuration. All the time we'll do this way. Now, after I do that, now the LEDs are ready. They are ready. I start to use them, right? So let's see how I made it, guys, here. Port P, okay, bit set for the first one. So this instruction, again, very easy. You have a byte. I'm gonna only 1 bit, the least significant bit. If I put 1 in this bit, you are gonna turn the LED on. You put 0, turn it off. Very easy. So here, bit set for this pin. So that means I'm gonna turn it on.
Okay, so I'm gonna turn it on, as I see here, and then these two instructions to make a delay 1 second. So forget it now. I'm gonna explain it right now. So now I'm gonna pull BB0 high to turn the LED on, and then I'm gonna come here, wait 1 second here. I'm gonna explain it. Okay, now bit clear. So now I'm gonna pull BB0 low, 0 volt to turn the LED, then wait 1 second, and then go back, repeat again. Very easy, right? Just you have 1 byte. I'm gonna only 1 bit, put 1, wait 1 second, put 0, wait 1 second, repeat. Very easy. Okay, guys? Any questions? Okay. So after the configuration, now I can start using port B. Okay. Anyway, so there are now I want to talk about this one, guys. How can you? So you are telling me when I come here I'm gonna wait 1 second. How can you wait 1 second? How can you do that? I'm gonna tell you how. Okay. Look at the idea. We have a subroutine. This subroutine is called delay Y millisecond. This is the name of the subroutine. There is a subroutine. This subroutine is called the delay Y millisecond. So this subroutine should make a delay Y millisecond. What is Y? Y is register Y. So if I put in register Y 5, number 5, we are going to make 5 millisecond delay. If I put in register Y 100, so you're going to make 100 millisecond delay, and so on. Okay, that is why before I call the subroutine, I put 1000 here in Y, and this 1000 is decimal. It's not hexadecimal. It's 1000. Okay, so here I put 1000 in Y, and then I call the subroutine. The subroutine is going to make 1000 millisecond delay, which is 1 second. You got what I'm saying? Okay, that means, as you will see in the video shortly, that means if I remove this number, I make this number 500, that means I'm gonna make, sorry, I'm hard to write, but if you make it 500, that doesn't mean you are gonna make a delay 500 millisecond, which is half a second. That's true. So you can see the flashing will be faster. Flashing will be faster, okay? Same thing, I can make it 100, just a number. You can play in this number. You can just play in this number just to make the flashing faster, slower. Not only that, that means you can generate a square wave easily. This square wave should have like different frequency, as you will see later, with different frequency, easily, very easy. Just play in this number, in this delay, right? So I pull the pin, I turn the LED on, so I have to wait for some time. I can control how much time I can wait, right? And then turn it off, wait some time, and repeat. Is that okay? Very easy. Just you can control this number here. Okay. Any question, guys, so far? Okay. So now I'm telling you, I have a subroutine. This subroutine is called delay Y millisecond. This subroutine is going to make a delay with Y millisecond. Register Y, whatever in register Y. Is that okay? So how this subroutine works? I'm going to explain to you how. Very simple. Look here, guys. Very simple, very interesting. Look here. This is the subroutine. This is the subroutine, as you see here, guys. Delay Y millisecond. Look how I made it. Very interesting. So the idea is, you'll see what I made here. Look, the idea is, look here, guys. Push A. Look here, I'm going to start from me. Push A, bull A, push A, bull A, push A, bull A, push A, bull A. What are you doing? Are you playing? Yes, I'm playing. Okay. So push bull, push bull, push bull. What are you doing? I'm wasting time. Yes, I just want to waste time. Okay. Because to push, I'm gonna take 2 cycles. To pull, I'm gonna take 2 cycles. So I'm gonna waste some time. That's true. So, and then this one, I'm gonna make loop. I'm gonna loop back here. This one should take 3 cycles. So I'm gonna keep looping, as you see here, guys, 1000 times. Okay. Look at the idea. 2 plus 3 plus 2 plus 3 plus 2 plus 3 plus whatever. The total here is 24 cycles. So this block this block of instructions, these instructions are going to take 24 cycles. And as I told you before, if our clock, the clock is 24 megahertz, 24 megahertz, right? That means the time is 1 over 24 megahertz. This is the time for one cycle, which is 1 over 42 milliseconds. Is that right? This is the time for one cycle, okay? That means this is the time for one cycle. That means if I have, sorry, it's microsecond, okay? That means if I have 24 cycles, that means it's 1 microsecond, right? That means from here to here, this is 24 cycles, right? So the time to execute this instruction from this one, all this instruction is going to be one microsecond. Is that okay? So this instruction is going to take, I'm going to waste 1 microsecond. Is that okay? If I repeat this part 1,000 times, the total will be 1 millisecond, right? So look here, guys. So this part is just 1 microsecond. Then I'm gonna make loop 1,000 loops. Okay. Here. So from here, this is 1 microsecond as you see here. But when I have a loop, when I loop 1,000 times, I'm gonna make 1 millisecond. Very interesting. Why it is very interesting? Because can you imagine in just 1 millisecond, I can execute this block of instruction. I can 1,000 times just in 1 millisecond. Is that okay, guys? So what I'm saying is that this part of instruction are going to take 1 millisecond. I'm just wasting time. I'm just executing an instruction. This instruction, I'm not doing anything. I just want to waste time. Push, pull, push, pull, push, pull. Right? Just to waste 1 millisecond. And now, how much delay do you want? I want a Y millisecond delay. So, and this part here is going to make 1 millisecond. So I'm going to repeat it Y times. And that's what I did. Look here, guys. So I'm going to repeat this part Y times. So I have a block of instruction. This instruction are going to be 1 millisecond. I'm going to repeat it Y times. You can see it. This is how it works. Any questions? Any question, guys? So I'm going to teach 10 minutes more, and then we're going to have 10 minutes break, and then we're going to have a test. Okay? You got the idea? So let me summarize what I said. Very simple. What I said, we have a subroutine. We can use it all the time. This subroutine is called delay Y millisecond. Okay? This subroutine can make a delay with Y millisecond, whatever the value of Y. Okay? And then I explained how it works. The way it works, I'm gonna do here some instruction. Actually, these instructions are not doing anything useful. I'm just wasting time. Push, pull, okay? And then, but the time needed to execute this instruction from here to here is actually 1 millisecond. And then I'm gonna repeat it Y times. That's how I can make Y millisecond delay. Okay, guys? By the way, sometimes this idea is okay, but later in this course, you will understand we have other ways to make delays. Okay? You will understand later this is not the best way, or sometimes this is maybe okay if the delay is short, but if this delay is one second is a very long time. 1 second is a very long time for computers. For this microcontroller, 1 second is a huge time. You know, to make 1 second, I have to loop here 1,000 times. And in every iteration, I have to loop 1,000 times. That means, you know, this part here, the part here, I have to execute it 1 million times because this one is 1 microsecond. So this instruction, the instruction you are saying here, I have to execute them 1 million times to make 1 second, right? 1 second is a huge time. But anyway, for now, later in this course, I'm going to explain a better way to make delays instead of this idea, okay? Okay, but anyway. We have another subroutine. We use the same idea. This subroutine is called delay Y microsecond. Okay, we just use the same idea, but this one is gonna make a delay y microsecond. Okay. By the way, listen to me. Okay. By the way, this subroutine is not very accurate. Okay, this subroutine is not very accurate. You know why? Because to make it simple, I discarded several instructions. So actually, it's going to be more than 1 second. Okay, why? Number one, have you counted this push? No, I didn't. Have you counted this pull? No, I didn't. Have you counted RTS? No, I didn't. Have you counted here when you come here? The jump is going to take some time. Have you counted the loot? No, you didn't. However, it should be okay. Why it should be okay? Because you are going to have 1.00001 second. You are not going to feel it. You get what I'm saying? Because these 4 or 5 instructions are going to take nanosecond or very, very short time. It should be okay. So if you need 1 microsecond, you are going to take a little bit more than one microsecond, which is okay because 1.0001 should be okay. However, if you want to make a short delay, you are going to start to feel the problem, and that's what you are going to do in the coming lab. For example, here, especially here, this one is in microsecond. So now the delay is short. So if you have a small error, the error now you can feel it here because it's a very short delay. Okay, and that's what I'm going to ask you in the coming lab to do. In the coming lab, you are going to use this subroutine to generate a score wave, right? So you will see when the delay is very short, you may have some inaccuracy. Okay. Anyway, any questions? We still have 6 minutes. Okay. No, should be okay. It's 1:15. Let me see. Just 5 more minutes. Okay, that's it. What else do you have here? Any question, guys? Very simple idea, right? Very simple, very interesting. One more thing I want to tell you guys here. All the programs I'm going to teach in the slides here, in this chapter and next chapters, okay, chapter 3, 4, 5, all of them, I post them on the course website. So you can find all of them on the course website. You have the board, you have the program, you can try them, and after you try them, you can just modify them to learn, okay? So that's why you can see here, guys, I put the names here. So if you want to look, if you want to search for this program, this is the name you have to use. So if you go to the course website, you will see what I'm saying here. So here, what I'm saying here, guys, this is chapter 3. This is a revision on C language. I'm going to explain this one. Yeah, look here, guys. This is this chapter 3. C and assembly programs are here. So if you download this one, and it's zip file, you should unzip this file. Once you unzip this file, you will find all the programs. We tested all these programs. So we made sure that all of them are working. Okay, this one thing. For every chapter, I did that. So if you go to for chapter 4, same thing here. All the programs are here. Chapter 5, I think the same thing is here. Okay, assembly and C. So this is one thing. Okay. The other thing is I want to show now the video for this flashing. Let me go to. Yeah. So let me see here. So yeah, so this is the first part. I was just playing. Look here, guys. So I'm just playing the delay. In the beginning, I tried to delay 1000 and see what's going to happen. And then I tried to delay at 500 and see what's going to happen to the flashing. For sure, the flashing should be faster, right? Then I tried 100, and then I tried 5 milliseconds. I want to see how 5 milliseconds looks like. Can you see? Your eyes can see flashing 5 milliseconds? I don't think so. You can? I don't, unless you have like a super eyes, something else. You will see. I was playing, so let's see. So I made the delay 5 milliseconds, and let's see what's gonna happen, right? You can see flashing every 5 milliseconds. I don't think so, but anyway, let's see. So in the very beginning, I just made it 1,000. As you see here, this is a normal one, I explained. So you can see flashing, guys. You can see this one is flashing. On for 1 second, off for 1 second, on for 1 second, off for 1 second. It's okay. You can make it 2 seconds, 3 seconds. You can control it easy, right? Now I'm gonna make it, I think 500. Let's see what I made. Yeah, sometimes I need to reset to connect again with the board. Sometimes I need to reset. So here, look here what I did. I'm making it 500. Yeah, so you should see fast flashing, right? 500 milli, half a second should be faster, as you will see right now. Look, it's faster flashing, right? Now I'm gonna try 5 millisecond or very small number, 10 millisecond. I'm not sure how it's gonna look like if it is 10 millisecond, okay? I'm gonna make it like 5 millisecond, I guess. 1 millisecond, okay. So every device needs some time to turn on and some time to turn off, right? So as you will see right now, because I'm going to do it very fast, what you are going to see, the LED is on all the time. Okay, you can see flashing. It's going to be looks like on all the time because you are doing it. You put 5 volt for a short period, then you remove it, then put 5 volt, remove it very quickly. You got that thing. You just keep it. You keep the 5 volt just for one millisecond, right? So you will see it like on all the time. Because the device itself, it needs some time to turn on and turn off because there are some electrons have to move from here to here. And microcontroller are very fast, 1 microsecond is short time. Look here, it's on all the time. For some reason, I don't know, this one turned it on, it shouldn't. So I'm trying to hide it from the camera. So yeah, just forget this one. Yeah, just look at this one. This one on all the time, right? So it should be okay. Ignore the other one. I don't know. It may be a problem in the board. You can try it on your board and see what's gonna happen. The other one should not turn on anyway. So this one, you can feel like it's very stable. Okay, guys. Any questions? Okay. The last thing I want to say here before we end this lecture, just last thing. Look here, guys. In this chapter and the coming chapters, I'm going to teach many subroutines like delay y millisecond, something like delay y millisecond, just to make programming easier. Number one, I'm going to teach you all the subroutines because you should understand how these subroutines are made. So I'm going to teach all of them. However, for exams, for final, for whatever, I'm going to ask you just to use them. If you know how to use them, I'm totally happy. You get what I'm saying? But I'm going to teach all of them. So I'm going to teach many subroutines. Subroutines, how can you write some value here? Okay. Many subroutines also here. How can you read a keystroke from here? Okay. So, and you have in your program, you have to copy these subroutines and put it in your program. Is that okay? However, I tried to make it in a smarter way, also easy way to make programming easier. Look how I made it. Okay. So I made it in such a way that you don't need to copy and paste, because you don't need to copy the subroutine and put it in your program. You don't need to do that. What I did, I put all the subroutines in one file, and you can just include this file in your program. That's it. Understand what I'm saying? Just to make it programming easier. You don't even need to copy and paste. Just I put everything in one file, all the subroutines in assembly I'm going to teach. I put all of them in one file, and then you should include this file in your program. Okay? So how can you include it? So that means once you include it, you can use all the subroutines.
because it's like all the subroutines are already in your program. You understand what I'm saying, guys? Just to make it easy. So you don't need to copy and paste, just include this file, and then all the subroutines are already in your program. You can use all of them. Is that okay? How can you include? I'm going to tell you how you can include. You know, if this is your program, I'm done. I'm going to just finish this one. So look here, guys. In your program, you should have org, as I explained before, org 1000, as I explained before, and all your data definition should be here. And then you should have org 4000, and this is your program is here. What we did so far, it was the main program. We didn't have a subroutines. So all the labs we had before, we didn't have subroutines, just the main program. So the way you have to do it is, subroutine should come here. After the main program, you have to put the subroutines here. Okay. So all the subroutine has to be here after the main program. Is that okay, guys? Instead of copy and paste, what you are supposed to do is you have to copy the subroutine and put them here. Right? I came up with a better idea. You just include the file here. Once you include the file here, all the subroutine are going to be copied in your program. You can just use it. Okay? So it means you have to come here and you have to use include instruction here. Include instruction. And you just include it here. Is that okay, guys? Some students got confused and they included it here as we did before. You remember we already include the file here, right? No, you shouldn't do that. Listen to me. Why? Because this file has equate. And usually we have to put equate here. This is the location for equate. So it's okay to put this file here, the file we included before. But this file has instructions. So it has to be in the instruction area. This area for code. So it has to be here. Okay. Anyway, so number one, what is the name of this file? This file is called subroutines.include. This is the name of this file. Number one, this is a file you have to include that has all the subroutines for assembly. Number two, how can you get this file? You can find this file in the programs. So if you download these programs here, chapter 3 slides are here, programs are here. So when you here, you can find this file here. Okay, guys, you can. Then I also make a tutorial for you to see how can you include it. Is that okay? Make a tutorial. I'm going to show this tutorial to you. Listen to me. Look here, guys. The file you included here in the previous labs, you didn't need to copy the file and put it in your project. You didn't do that. You know why? Because this file came with Code Warrior. So Code Warrior already put the file there. So you don't need to copy the file and put it in your project. However, because this file, I created it. It doesn't come with Code Warrior. Okay? So you have, if you put this way, Code Warrior is going to give you error. It can tell you, what is this file? I never heard about this file. So you have to copy this file by yourself and put it in your project. You got what I'm saying? How? Very easy. I have a tutorial here to show you how. I'm done, guys. I'm sorry, I'm done. I'm not teaching anything new, just I want to finish this part. So I have a tutorial here, very easy tutorial. You can find it in the course website. Okay, guys. So this is the tutorial here. You remember this include, guys? This include, you don't need to copy this file and put it in the project. This one here, right? Why? Because this one comes with Code Warrior, right? So you don't need to do it here. However, so here in your project, if you open the folder called includes, you can see all the files that's already included. You got what I'm saying? So this one is included, this one is included, right? Now you have to copy my file and put it here. How? As you see here, guys, you can copy to this file and then right click and then you select add files. Okay? Once you select add files, now you can go to your computer. You can select this file. This file has all the subroutines.
you can open this file and you can see the content of this file of subroutines, all of the subroutines, okay? Like delay YMS. So, and then you can select this file, okay, as you see here. So you have to select it. Once you do that, oh, now you have to see it in your project this way. Very important. That means if you don't see this file here and you try to use any subroutine, you try to include this file, code error is going to give you error. Code error is going to tell you, I don't know where is this file. You know what I'm saying? So again, you have to make sure when you open include, you see the file here. Okay, guys? You should understand why this file is different from this one. This one, as you see here, this is the one we include all the time. This one comes with code error, but this one it doesn't. This one I made, so you put it here. This number one. Number two, how can you include? We are going to use instruction exactly like this one, but I'm not going to put it here, as I told you. If you put it here, only equate. This is the area of equate. Equate are here. Data are here. Code is here. So you have to put here at the end because it's a code, right? That's what I did. So you have to come at the end of your program. This is at the end of your program. I'm going to write it this way: include subroutine.inc. Is that okay, guys? The last thing here you have to do is these subroutines. In these subroutines, I use a variable called counter. Okay, in one subroutine, I use a variable called counter. So you have to define this counter. Otherwise, you have to define this variable. Remember, when you include a file, you know what you did? What did you do when you include the file? When you include the file, it's like you copy all the subroutines and put it in your program. Copy paste, right? So you copy all of them. So if you forget to define a variable called counter, code error is going to give you error. It's going to tell you you are using a variable called counter and you didn't define it. You're going to be, so no, I didn't use a counter. I didn't use a variable called counter. Yes, you did, but it's already in the subroutines. You know what I'm saying? So anyway, so also you have to. That's what I'm explaining here. You have to define. You have to in the here in the definition, in the data definition. You should define a counter, a byte count. It's called counter, as I did here. Okay, so you already have this. In the next lab, you will do it, so don't worry about it. It's going to be, you will like it. One, because all the subroutines are in one file. So you don't need to worry, copy and paste. You can just use all the subroutines. I'm going to teach you this course in a series. Any question, guys? Okay. Great, thanks. That's enough for today. We're going to take a rest. We are going to start 6:15. Okay, 13 minutes.